Hi, welcome back. So we are at the case study of this section. In this case study, we are going to try to bring most of the information we have learned so far, not only from this section, however, from previous sections as well. So the basic idea of this case study is centered around reading a website. Let us assume we have this website which has a very basic and simple structure. There are some kind of links to different web pages. And if you click at one of those links, of course, you can expect that it's going to link you to another page. So now we are inside another page. And inside that page, you might end up to have links as well, plus text, of course. So what task we are trying to do? We're going to have kind of a dictionary. And inside that dictionary, what a key, of course, and its value. So in this case, in the key, I'm going to speak about the main link of the website. In this case, for example, I have main link for contact us here. And what are the value I expect to be? Another dictionary maybe, or a list. Let's make it a set, even not a list. So we're going to make sure there are unique links. So some of them can be duplicate in the website. So this is a very good example to see how we use set inside Python. So what happened when I have the contact us main link here, its value is going to be a set of other links within that page. So you get a link for my blog, the home, the contact, etc. So these are going to be listed inside here. There are some of these pages could be locally inside the same website, or can be maybe direct me to outside the web page, so to another server, so to speak. Some of them are HTTP protocol, some of them HTTPS protocol. But the major idea is going to be centered around this. So we're going to create this kind of a dictionary. One, the key is going to be the main link, and the value is going to be a set of all the links inside that page. If it happens that the page is not read, like if it's external, like in this case, I expect then the set to be empty. Otherwise, the software or our program should be able to read the links within each and every page. So to kick off and start up with this program, we need to make a structure. What is the general idea? Once again, for the analysis, the design, etc., I leave it for you. Think about the problem on your own. I have already written the simple software, which I'm going to be sharing in the GitHub of this training program, and I will just walk you through the idea in general. So there are some of those libraries we will be able to use. And luckily, those modules provide us with so many good functionality that instead of reinventing the wheel, they are already there. Start with this module from the URL library called the request, which has something called URL open. As the name implies, you give it a URL, and the module will be able, or this class will be able to open the website, load it, and read the content. And there inside the same module, there's this another class or module, actually submodule called parse, which has, as the name implies, that you can parse the link that you pass to it. There's one more called the RE, which actually we will have, I think, some session to discuss how we can actually utilize this RE modules to do some good work when we want to kind of a parse a link or make a kind of a serialization on certain input, etc. Actually, I imported the sys system here, but I'm not going to use it because I was thinking to provide the link in the argument. So I changed my mind finally, but I left it. And if you want, you can just get rid of that. Of course, we're going to import the queue. And the idea of the queue can be very useful here because I don't need to check every other element inside the queue, but rather the first input to that queue I will be dealing with. And then I have this RE compiler, which we're going to be talking about it briefly. Of course, there are better reference to look at. So this particular structure of parsing, it's not my own creation. You can check the documentary for that. Now, in this particular example, I relied on the idea of creating major main class called the link collector. So the link collector is going to do the whole job. So I didn't want to make any other object instantiating anyway. As you can see, the link collector in its dunder, and it will receive a URL, the main URL. The first thing we want to make sure actually to parse the URL from the HTTP if it's provided, because it's for testing mechanism. So whatever you're going to give, the link is going to be parsed down to the original from the HTTP up to the main server call, which is www. For example, google.com or etc. In this case, actually, we're going to be relying on a local server. So we're going to be using the localhost server. I'm going to show you in a while how to run from Python. It comes with a web server hosting using the HTTP and relying on the localhost. So here I have two kind of variables. One is a dictionary and one is a set. I think that explains exactly the mechanism I was trying to work on. So the dictionary collected links is going to have number of keys, and those keys will represent every main link in the main page that we're going to provide in the index. And then is going to map to set, which is going to contain all the links inside, belong to each one of those pages. So you're going to imagine this as a mapping from each key to each value. Now let's go to the first function called the collect links. As the name implies, of course, this is the main function I will be calling once I instantiate an object from the link collector. So basically, I created an empty queue here, and this queue now is going to be able to put some value in it. So the first thing I'm going to put inside that is the first URL that is provided after it has been parsed, of course. We can use that later. So I want to make sure to keep looping inside the queue as long as it's not going to be empty. This is the first entry to that particular call. So this is going to be looping again and again as long as the queue doesn't get empty. So here's the idea. We're going to create a variable called URL. So what we want to do, we're going to get the main from the queue. Now what is inside the queue is the main URL provided, which is the main page. So we're going to take it and strip down the last character of this backslash. Go to the self-visited links, which is the set, and we're going to add the first URL. Now this set contains this URL. Next, we're going to create the page to read and load and see how many links are there. So here I am relying on the URL open, a class from this particular module. So here just is the standard, make sure it's going to be a string after, of course, you read the page. So here I loaded the page, I call the function read, and it's returned. Now this will read the content of the page, and I put that in a string format. Now the page is a string format, contain all the text returned or read from the web page. Now here is what I am using, called the link reject, which is actually it's a compiled number of characters that is able to strip down and recognize a link inside a written text. So this format, you can check the documentary to find out more information. So what happens now, every link is provided inside the page will be able to be stripped down. Now the links are inside, or the return from there anyway. The return from there is going to be list of all those links matching this particular pattern. Now I have all the links. As you can see, some of them is going to be, for example, contact us, and once again is contact us. Some of the links will be read http.contact us. Some of them will be /contact us. So these are replica. We need to make some treatment on that. That's why I have created here normalized URL that expect to have two of those arguments. First is the path, and second is the link. So what we're going to do actually, we're going to provide the URL parse of the URL.path. So we're going to just parse that URL we have just stripped down here from the essential path, which is in this case our main local host. And then we're going to provide the link, where I want to make sure link is actually looping inside the link list that is returned from here. So I'm going to loop inside every link inside the links and make treatment. So what this actually normalized URL does in particular, actually nothing really special. It's just to check if the actual content of the link starting with HTTP starting with actually just only a slash. It means it's an internal website, or maybe it has a longer format. So all these format, I check them out. That's why I create this condition. And anyway, it's going to return based on that. So I will have a clean net kind of a set of those links all together. Then inside the self link collected here linked list, which is the dictionary, I'm creating a key. Now, here's the first thing I did. I managed to step down every unique link inside the main web page. Now, this link must have some other information inside, right? We said if you click that page, you could have other links. So here, this main link is going to have these links, right? Because we're going to pass it down anyway. And what happened now, we're going to loop inside those links, and then I'm going to set now the information inside the self collected links, which is the dictionary, where we're going to set value. So I'm going to give the link, and if you find the link is duplicate, then leave it. Otherwise, you're going to have a set. So if the link is exist or not exist, if you remember, we use the set value here. And then in the unvisited links, which if you remember, this is a new variable that we're going to create. It just makes sure that the links is different from the self-visited link. So every link inside this is not going to be duplicated. Finally, I will loop inside these new unique link. And then what I'm going to do, and make sure they are starting with the URL. It means they are passed through the main kind of URL. And then I push them inside the queue. Now the queue will have a new value. Once it has a new value, what will happen? It will go and loop inside that, and then keep doing this again and again and again until the queue is completely empty. That's exactly the main idea of this. Now, to run all of this, what we need first of all to create this kind of a main website. Of course, doing that, it's all up to you. So what I did, I just created a very basic HTML pages, and I made sure one of them should be named as index.html. Now, if you open this HTML, you should have this main page looks like this. So it's find all the link. This is the main page. If I click on contact us, it takes me to another page, go back, go to blog, and so on and so forth. Some of them will work. Some of the links are external, like this case, for example. It doesn't have contact, so the page is completely off. Some of them take you completely to external kind of server, like in this case, in the Arch Linux, etc. Now, what we want to do, first of all, we want to secure a temporary kind of a server, a web server that can serve and can open. And then we can proceed in here. Now, luckily, Python offers us an open source kind of a web server to make that kind of service. In this case, make sure to log and reach out to the same folder where your actual HTML pages are located. And they're just going to type python-m, and then you're going to say http.server. If you click, you will see the server is open, and I'm able actually to interact with that server. So as if I am running Relay server. Just make sure to open a new terminal so you can work along the line with that. So now the server is open. Now I get back to my script here, and I'm creating, I just make sure this script is going to run locally here. If it's run from here, otherwise can be used by other module. So here I'm creating an instantiator from the collector and passing the main name. And here is going to be, of course, localhost, because I know the server is going to run on the localhost namespace. Now then I'm calling the collect links. If you remember, this is the collect links. After that, I just will return all the information. And here what I'm going to do. I'm going to go inside the collector, which is an object. Inside the collector links, which is actually the dictionary, inside the items of that, and I am unpacking link and item. Here I'm calling the link in a tuple. Here I'm calling the item. Now the item will be a set and the link will be the link. Let's try to run this one and see what the result would look like. So once I run this, the result looks pretty much ugly, but you can, do whatever later on. So here is the main link, which is just reach out to the main local host. Okay, imagine this. And here is the set of the information inside that main page, which is actually true. We have link here, link here. This is actually the main menu. I'm talking about this page. So it has all these pages. If you read down, you get the contact, the blog, the ESME Hobbies, etc. We go inside the first link, which is this guy here. So now this is my first link, which I logged in. This is a key now. What is inside that page? If you open, you will see a set of other links. We have 3 links here. Now you go to another key on another page, you have an empty set, and so on and so forth. So that was all actually. Try to read this one. I'm going to tell you, this is not the best way to do this job, but it's just a suggestion and perfect to look at the general idea. We have reached to the last section of this training program, and that is to discuss an advanced collection or skill set of some ideas around the object-oriented programming, and in particular Python. Some of those information can be really useful while you are writing advanced kind of code or libraries or sections, software, etc. I'll try to pick up of these topics and put them in one particular outlines that can help you later on. I will see you then.